Alright, welcome to page 2. What I had to do was I went ahead and did this all by hand on my iPad and decided just to draw everything with my fingers. And because it took a little while, I decided not to record and just go over the answers. So to sketch the vector field by drawing a diagram. So all I gotta do is you're just going to pick points on your plane, since this is going to be, since it's f of x, y, we're going to be doing this on a plane. So I just pick points on my plane for x and y. So I start off with 0, 0, get the 0 vector, so there's nothing there. Then I plugged in, all values where x is 2 and negative 2, and all values that correspond with that, 1 and negative 1 for my y values. And what I get is, I get, pretty much just my links going up 1 to the left 1, down 1 to the left 1, depending on what value I get for those. And so I end up with, this vector field. And the more I correspond, I'll go ahead and try to draw one. The further I go out for x and y, if I go over to 4, my x is going to be 2, and I go up to say y is 2, then I'm going to have one that looks more like that, where it's going to be longer the further I go on the x, but still not going as high as my y. And then I can do that for left and right. When you're doing this, I would prefer you do about 8 of these. I only did 5, really 4, because of the 0, 0 vector. I really don't like that because you don't see anything. So I gave you about 4, but then I'll also put a few on here that are pretty easy, like when I did some on the x-axis and the y-axis, if you can see there as well. And so again, I prefer at least about 8, but again, the more you have an idea of what the surface is actually doing, or what's going on at that plane. All right, get off of that. So the next one, negative yk, this is on 3 dimensions, and so I did probably easiest. I just kept, I made z equals 0, just so you can get an idea for our points. So all of our points are going to be a plane, but you're still getting the 3 dimensions as we go along. And since everything corresponds to where z is negative k, so another reason why I went ahead and made that 0. You can see as we move along the y-axis in the positive direction, your vectors are going down, and the further along you go, the further down they go. The further you go along the y-axis in the negative direction, they're actually going up because it's negative y, and it increases that way. All right, now let's go ahead and look at example 3. We're going to match the vector fields, and so we're going to go ahead and start off with 11. So 11 corresponds to graph 4. In the first quadrant, you can see all the vectors have positive x components and negative y components. In the second quadrant, all the vectors have a negative x and y components. In the third, you have negative x and positive y components. And in the fourth, you have in the fourth quadrant, all your vectors have positive x and y components. In addition, the vectors get shorter as we approach the origin. So again, one thing when you're looking at these is, okay, you know what values you're going to get when you get to quadrants. You know that, in quadrant 1, x is always positive, y is always positive. And so I can look at, the function that I have. I got my components and see, okay, which one matches that. So for 12, looks like we correspond to graph 11. And again, how we can tell that is that all the vectors in quadrants 1 and 2 have positive x components, while the vectors in quadrants 3 and 4 have negative x components. Again, if we go along the y equals x, our horizontal vectors get shorter as we approach the origin. Again, you have to really zoom in to see the y equals x. They are getting horizontal. 13, the function y plus 2 corresponds to our vector field 1. Again, just like 12, all quadrants 1 and 2 have positive x components, while all vectors in quadrants 3 and 4 have negative x components, and vectors along the line y equals -2 are horizontal, and the vectors are independent of x. And so, again, you can see, again, use that information as well, especially whenever you make y equal -2. When we look along, okay, what will that give me? And it will give me those horizontal lines. All right. For 14, it corresponds to the last one. Yes, corresponds to graph 2. And how we know that is all vectors in quadrants 1 and 4 have positive y components. All vectors in quadrants 2 and 3 have negative y components. Also, the y components of vectors along any vertical line remain constant while the x component oscillates. All right, that does it for page 2. Now we're going to move on to page 3.